dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Digital transformation has failed to take off because it hasn't removed the endless mundane work we all hate. Automation can solve that by taking on repetitive tasks for us. Unleash your potential. UiPath Reboot Work.
Good, thank you.
Happy to be here.
Well, we are going to, well, first of all, we're just going to say, who is UiPath, but then we very quickly just talk generally a little bit more about AI and machine learning. So kind of to, frame a bit the understanding. Then we'll talk a bit about the UiPath product and machine learning, what are the components and so forth, so that people understand what is machine learning and UiPath all about, kind of from a product perspective. And then we'll deep dive into an example, and Radu and Andreas going to drive this. Yeah, I think it's pretty exciting because you come from the theory down to a very practical what it actually means. So practical AI is what we actually want to show you today. Okay. Okay. Hi, everyone. So, well, thanks for taking the time and being here. I hope you're gonna enjoy it and get lots of new ideas from what we are going to tell you today. So I just wanted to kind of give a quick start just to tell you about who's here, who are we. I'm Boris Krumrey. I'm the VP for Automation Innovation. Been with UiPath for quite some time, talking about product and kind of invented what we call the UiPath Immersion Lab. And in this lab, we are tinkering around with lots of customer challenges, build prototypes, many of them all around AI and machine learning. And that's exactly done by my colleagues here, Andreas Palfi and Radu Pruna. They are both kind of really our AI wizards. But the good thing is they are not just kind of wizards deep down in the code. They also are really good in explaining and articulating, the challenges and how you solve them and so forth. So they're really amazing talents, and I'm really lucky to have them in our lab. To give you a bit more background about UiPath, it's quite an unusual, unique journey we have taken. So we basically, our core of our product is robotic process automation, which emulates a user or person. But you could imagine that the biggest challenge around this is actually to understand the screen that a person would be seeing and being able to extract all the information in a very intelligent way. If we wouldn't have done that in a good way, then this software would not have grown. So anyone who tells you this is just simple screen scraping is in big error. And as we, when we started our journey, when we I think I would say around 2015, we really kind of started in a rather big way in terms of seeing more and more customer using that to automate their operations, particularly in the outsourcing space and so forth. We realized that this is actually the foundation of something bigger. And so the product today would be not just RPA, it's a embedded machine learning engine, it's process mining, it's task mining, it's a whole environment to develop applications, web applications, database, whatsoever. So it's really a lot more. I'll talk about this later on a bit. But the key thing that you're seeing here is we've kind of rapidly grown. So only in the last 4 years when I joined, I mean, we've made such a big difference. And we have been actually the #1 leader in robotic process automation since 2017. And we were kind of keeping that place. And not only that, analysts like Gartner and Forrester are saying that, we're #1. It's also independent reviews, which we are very proud of, that, give us a thumbs up of a solution, of a software that is very easy to use. Our software, we have a community edition that is free, which you can use, even including the trainings. Which also leads me to kind of the key thing, which I already kind of related to and explained around our software, which is kind of the core of it, is the emulating the user. Now, the key thing is that even in that core, we are already using AI technology. We're using computer vision to identify all the objects on the screen. So you can easily just drag and drop an image of a screen into the workflow, and then you'll be able to address all these fields that are in the screen. You can kind of combine them with other elements on the screen, and to make very sure that you're extracting the right position and so forth. But the key essence actually is that we have combined it with a deep learning network that is trained on all the graphical objects that you have on a screen. And with that, like the human eye, like we do. It understands what a button is, what a table is, and so forth. And so it doesn't matter where it all is. And why is that so important? Well, it's important because you want to make that robot as reliable and resilient as possible. So if you imagine if it would have really been simple screen scraping, then as soon as something changes on the screen, people would have to retouch the code and the workflow and so forth. And of course, that would have never kind of made a big development in the market. But as we have created much more intelligent means to extract information far more reliably and enter that, it's of course, it made a much bigger difference. But we are actually the only ones who combine computer vision also with our robots. So we're not just going into the operating system and extract the selectors of the screen and so forth and combine that with intelligent anchoring. We actually also use computer vision. And that really makes one big difference of how our robots work. The other aspect is that we use APIs, we use the user interface. So and then all the products around it. And this is where I'm saying, RPA has now just maybe been the core of it, but all around it, we implemented tools for process discovery. So process mining, if you already know what a kind of process you want to look at, you connect to the backend system, SAP, ERP system, and then you look into the logs and you find exactly which particular kind of activity has been done. And then you can visualize that and you can see how much time has been spent, how many paths somebody has taken with a certain transaction. So there's a lot more. But one other thing that we have added is an AI engine. So it's not just for doing kind of intelligent document processing and OCR extraction. It's also that you can upload and configure any kind of machine code. Python code as you usually would do in such AI and machine learning areas. So the key thing is here around, we create this automation layer on top of applications. And that's kind of the key essence of what the software does, and it's much broader. So today's agenda, we're going to talk about the introduction of machine learning. We are going to talk about machine learning at UiPath. So how does it all look and be set out in the product? And we then go really deep into the demo. So to give you a real kind of more practical experience around this. So with that, I'm handing over to Andreas, who's going to give you an introduction to machine learning.
Thank you for the introduction, Boris. So let me just start sharing my screen. And we're going to dive a little bit into what exactly is machine learning. Okay, so as Boris mentioned, we're going to start out with a quick introduction into what machine learning is and what are the main challenges of implementing machine learning models and actually using them in a real life scenario, integrating them into a business process, into a business flow, because that is the end goal of all machine learning models, basically being able to use them within a business process. Okay, so we're going to focus on three main things. First, just to understand what machine learning is. Then we're going to quickly look at the types of machine learning that are used out there in real life scenarios. And at the end, we're going to have a look at what it takes to implement a machine learning project and what are the main challenges of it. Okay, so quick introduction to what machine learning really is. Well, machine learning really refers to a collection of techniques that allow computers to learn from data. In other words, it basically is a collection of algorithms that use data to create models, because a model is just a way to formalize the knowledge that you have about a certain phenomenon or a certain process. For example, like using historical data, machine learning algorithm could create a model that describes the relationship between spending behavior and the probability of fraud. And this is something that a lot of banks are already doing. So when you do a card transaction, the bank is actually verifying this. Was that transaction fraudulent? Because in case of somebody hijacks, let's say, your bank account and wants to make a transaction, they can stop it in time. So that's a very good example of a machine learning model. But what is a model? Well, a model is a mathematical way to approximate reality. In machine learning, most models can be expressed as like mathematical function. This is something that we have all learned probably in school. So a function is an expression that can be used to describe a relationship, more specifically a relationship between an input and an output. And a very good example would be something that maybe all of us can relate to, like describe the relationship between the size of a house and its price. And that's exactly what you can see on my screen right here. So we have a function that tells us that, okay, the price of a house is $15,000 plus 5,000 times size in square meters. So we have a function that uses the size of a house to try to describe price. So for example, if we have this house here, that's 100 square meters, we can very easily estimate the price of this particular house using this function. You know, this house would be like $500,000 US. Okay. However, if we want to describe a relationship between the price of a house and its size, we need to find the right function. So the question is, which one is the right function? You know, because we could use so many different functions to describe this relationship. How do we find the right one? How do we know which is the right one? Well, this is exactly the problem that machine learning is trying to solve. So the right function is the one that best describes the relationship between the size of a house and its price. So the objective of machine learning will always be to find that best function that describes the relationship between an input and an output. And this is what basically all machine learning models do. Whenever you hear about like a fancy deep learning model, they're all basically trying to create functions, approximate functions that can basically describe the relationship between an input and an output. So how do they find the best function? You know, these machine learning algorithms. Well, they do it by looking at data. They estimate functions from data. So if we want to find a function that best describes the relationship between the size of a house and its price, we need to collect samples of data, historical samples of data, and feed that into our machine learning algorithm. And that's what the algorithm is going to use to learn from. And these data sets in machine learning are usually composed of several parts. You know, we have this terminology that we use in machine learning. For example, in a data set, we have features, descriptive features. These are like measurable properties or characteristics of a phenomenon that's being observed. For example, if you're trying to predict house price, we could have the size of a house, the number of bedrooms, the location, you know, all these features that can be used as a way to maybe tell the price of a house, that could be used to predict the price of a house. And then we have the thing that we're actually trying to predict, you know, the target feature, the label. This is what we're trying to estimate. So input, output. And then we have examples. So we have historical examples, the features of a house and its target price. And this is the type of data that usually machine learning algorithms learn from. And of course, we can visualize this data using a graph as well. So looking at the graph, we can see that right here on the x-axis, we have size in square meters. On the y-axis, we have house prices. And as you can see, it seems like there's a clear relationship between house size and house price. So every point on this graph is basically a particular house from our historical data set. So using this sample of data, a machine learning algorithm will try to explore several functions to find the one that best fits the data. So it's going to look at all of these different functions, in this case, let's say different lines, and try to find the best one. And in this example, the best function will be this line, let's say, that you can see on my screen. Okay, so why is this important? Because once we know the best function, we will be able to use it to predict the price of a certain house that's not in the data set. You know, we can use this function, this model, to predict house prices. So if we know that a certain house is like 110 square meters, we can tell using this function that its price is going to be, let's say, $230,000 US dollars. So this is why machine learning models are very useful, because they take data, they learn a model from that particular data, and then you can use that model to make predictions, to make decisions. So for example, in this case, we have some data about house sizes. We want to tell its price, you know, and we can use this model to try to approximate the price. And of course, this is a very simplified example. You know, in a real world scenario, in order to approximate house prices, you would need a lot more features and a lot more examples that you have seen on my screen, because certainly size is a good predictor of price, house price, how much a house costs, but it's not the only predictor. There are a whole lot more features that go into telling the price of a house. Okay, so this is what machine learning is in a nutshell. This is what all models do. They try to estimate functions, meaning that they create these models that can help us make predictions, help us, you know, describe the world. And there are different...
maybe one question here. Just how do you compare, for all the software developers and people that have more experience in traditional programming, how would you compare the two approaches? The approach of a traditional programming, where I actually write the instructions for the computer, versus this machine learning approach where I can't really do that?
Yeah, that's a good question. So a model can be thought of as a set of rules, you know, a set of if statements. If this, then that. In a traditional, let's say, programming paradigm, you would need to manually write all of those different rules that can tell us the price of a house. Let's say you would have thousands of if statements that say if house size bigger than 130 square meters, and if number of bedrooms smaller than 2, if location is here, you know, a whole set of rules, then price is equal to this, you know. However, machine learning model basically is able to look at data and then deduct those rules, you know, so you don't have to specifically input and write down those rules, but they are learned by the model itself from data. So this is the biggest difference between these two different, let's say, paradigms of creating these decision engines. And that's what all machine learnings do. And there's different types of machine learning models based on how algorithms learn, you know, how and what type of data they learn from. So I would say there are 4 main categories of machine learning models: supervised, semi-supervised, unsupervised, and reinforcement learning. The most common one is supervised learning, and that's when we have data that is already tagged with the correct answers. And most machine learning projects use supervised learning. So use these data sets in which we have the target, we have what we're trying to predict, we have all the features, and this is the data that the model is going to learn from. The other big category is unsupervised learning, in which we just have a set of data and we are trying to identify patterns from that data set. But I would say that the most common real-world use cases of machine learning are supervised. And that's, as I said, that's where you have a training data, you have labels, you feed it into a machine learning algorithm. So that algorithm gives you a model, and then the model can be used to make predictions on new data. And of course, there are two subcategories of supervised learning. One is classification, when you're trying to predict categorical variables. So, you know, answers like yes, no, is it spam email, or you know, try to, if a picture it contains a car or not, you know. So predicting categorical variables. What the other type of supervised learning is regression. So this is the process of predicting continuous variables. So for example, the price of a stock. So you're not dealing with categorical variables anymore. And here you can see a whole list of use cases and applications of supervised learning. So basically, you can find an application in any industry for machine learning. So in automotive, you can do predictive maintenance when a car is going to have a breakdown, you know, when some piece is going to fall. Or in retail, you could do inventory planning, or something that we experience ourselves, recommendation engines. You know, just think of Netflix, how it's recommending you movies, or YouTube is recommending to. So YouTube, for example, has an amazing algorithm to recommend you videos. You know, it always knows what you would like to watch. And the same goes for the rest of the industries as well. I would just like to mention one specific example of machine learning that we do at UiPath, and this is something that Boris has mentioned as well. So we have these computer vision models that allow you to identify UI elements. So basically, an image is being fed to a model, and then that model identifies all of the different UI elements that the robot could interact with. So basically, it gives our robots this ability to see and understand screens. But I think this is something that Boris is going to also talk about a little bit later on. It's just, this is a very good example of supervised learning, because the way we train this model is we showed it, you know, thousands of different examples of UIs, and it learned from that how UIs generally look like, you know, how a UI look like, regardless of what type of system of software. You know, it could be Excel, it could be Word, it could be a form, whatever. Okay, and now let's try to understand how machine learning projects come to life, and what it basically entails to do a machine learning project. I would say, first and foremost, to build a model itself, these are the 4 different processes that you should focus on, that you usually focus on. And it always starts with, you know, data processing, getting the right data for your particular use case. Then there's, of course, the training, when you actually train a nice process data set. You train a model on that nice process data set, and you try out different algorithms, you know, and that's where evaluation comes into place, because you're going to try out several different types of machine learning algorithms. You're going to get several different models, and you're going to have to test which is the best model for your specific use case. And that's why you always split your data into a training data and test data. You know, you use one data set to train your model on, and the other data set to test your model. You know, this is a very high level overview of how you do machine learning models. And once you're done with that process of training several different models, evaluating them, finding the best one, then you have the prediction phase where you actually can feed new data and make predictions. So let's say, as I mentioned in the beginning, that fraud example, you have a model that can predict fraudulent transactions. You start feeding it transactions, and it's going to be able to identify which card transaction might be fraudulent. Okay. But this
question.
Yeah,
so
please.
Knowing that you guys are typical data scientists, so what's the scenario in terms of what do you spend most time on when you build a model? Do you just is it more the data processing? Is it creating training data? Is it what's the reality looking like in the data science world?
Yeah, that's a very good question, because most people would think that most of a data scientist's time is spent creating these fancy models, using these state-of-the-art models and fine-tuning them to get that extra 0.001% accuracy. But that's really not the case, because one of the main challenges is data processing, getting that right data, getting those right features, cleaning them, aggregating them. For example, let's say you want to build like a model that deals with historical customer behavior. And usually within a company, you have all these data sources of customer behavioral on a website, behavioral, maybe in a physical shop, email behavioral, and you would like to bring all of that together to get like a 360-degree view of the customer before even being able to build any type of customer behavioral model. So the main challenge is usually spent in data processing, and once you done with the data processing and done with the modeling part, the other big challenge is actually productionizing the machine learning model. So making that model available, as a service that can be used. So usually productionizing means basically two things. Means having the data pipeline, so the pipeline that can be fed into the model and that can be used to make predictions, and actually productionizing it, so making it available, having the right infrastructure to make that model available. And I would say the data engineering part and the model productionizing part is the two parts we're going to spend most of the time. And of course, there's one last step that is really, really important, and that ties into our RPA platform. And that is, a machine learning model on its own, it's not very useful. You need to have a way to integrate this model into an end user application. That means to think about the process that this model will be used in. And you're going to see a very good example for this be presented a bit later on by my colleague Radu. So you need to think about the process that this model is going to be used in, and think about how you can create an application around that process, that helps automate the business case, have automate this business case, this particular business case that you built the model for. Because usually these are quite complex scenarios that these models are being used in. So you have some data, the model is making a prediction, you have some human supervision on that prediction, you have some human decision making, and you have to have a way to orchestrate all of this. And you need that to be able to have a successful deployment of that machine learning model. Let's say you have a model, and this is something that you're going to see from Radu, that predicts which invoices are going to be paid on time and which not. And you need to think about how could the cash collection team use that model, and how could I build a solution that they can actually use using the business flows that they have today, to have them use this prediction that are made by the model, to actually put these predictions to good use. And this is exactly what you're going to see in Radu's presentation.
So, Andreas, one question here. So
yeah.
you've quite clearly explained the advantages of RPA on top of existing AI models in terms of, actioning upon the prediction that the model makes, right? So integrating this prediction of the model into a real end-to-end business flow. But then on the previous slide, when you talked about the different parts of a machine learning project, the one before this, what are other areas here in which our RPA platform can actually help you? Maybe in terms of data collection, or maybe not necessarily, okay, on the modeling itself, it's quite clear that using our machine learning platform, you can do all of these different things. But also, how can you use RPA maybe for productionizing the model, and importantly, monitoring, those exceptions and the challenges that maybe the first versions of the machine learning model are gonna have?
Of course. So yeah, we have, this is something that Boris mentioned as well. We have this engine, this machine learning engine that can be used to deploy machine learning models into production. And it's basically a way that allows you to very easily put this model and use it as a service, put this model in production and be able to interact with it, send it data and get some predictions back. So it basically takes, abstracts away from the infrastructure. It's a service. You package your model, you put it on there, and you're going to be able to interact with it. And that means being able to right away send some data to it and get back predictions. But of course, this is just one part. This is just only deploying the model. Then you also want to be able to maybe collect data that can be used to retrain these models, because once you put a model into production, it starts degrading its performance. It starts degrading, and that's just because this is how the real life works. Data sets change, the world changes, models don't have the same constant performance. Your customers change, their customer behaviors change, and as soon as you put the model into production, it starts decreasing in performance. That's why you also need monitoring. And again, this is something that you can do using our platform. You constantly need to monitor the performance of the model to make sure that it's still a good enough model. It has the right accuracy for your particular use case. And as I said, then you should also think about improving the model, constantly retraining it. And this is another advantage that like a machine learning model platform brings you. It allows you to constantly gather data. And there's all sorts of different ways that you can do that using our platform, using the UiPath platform. And it allows you to retrain these models with the hope of making them more accurate, and constantly updating them. And this is something that you're going to see in Radu's presentation as well. You're going to see how we used this product called the AI Center, this machine learning model deployment platform, to put the model that we created into production, and also how we use the whole, our whole automation portfolio, all sorts of products from our automation portfolio, to create a business application which uses that model. Okay, but before we dive into that, I'm going to give the floor back to Boris, who's going to talk about machine learning at UiPath. So what we do with machine learning models at UiPath, how we use them, what type of products we have that use machine learning. So Boris, I'm going to stop sharing my screen and give back the floor to you.
Yeah.
Let me just, okay, done.
Okay, great stuff. Thanks. I think it's quite interesting. One question I always have to you guys, because you're the data scientists, is there kind of a difference between data scientists and kind of developers, programmers? Is there is it a different kind of way of thinking and so forth. I hear different kind of things. What's your view here?
So I would say a data scientist is basically an accountant with very good programming skills.
Really? So you have statistical knowledge in it?
Yeah, because it's all about analyzing the data and understanding the data and understanding the processes. While as a machine learning engineer is somebody who's a very good engineer first, because most of the challenges with machine learning are engineering challenges, you know, having the right infrastructure, creating these pieces of software that have a machine learning component in them, you know, and for that you need very good engineers. So machine learning engineers are very good engineers first, and then usually machine learning scientists second, because that's what you need to build enterprise grade machine learning models that get used by thousands of people or millions of people, you know, as YouTube, as Google has and Facebook has.
Great, thanks. But it kind of weaves into the next topic a bit more, because I'm not just gonna talk about, I will deep dive into the product a bit, but also, you know, to give you a bit of a step backward, kind of, you know, how does AI applied really look like? What does it mean, and particularly in the current context? So let me show you this. So, and then what I want to allude to. So through the pandemic, actually, the whole development on digital transformation, or pushing forward, turning things into automation, into something digital, as customers are now all working from home and our consumer behavior has changed and so forth, you can reckon that companies are really pressured to become digital. And that all companies were set out for this. So the whole movement around automation, about our kind of technology, has always been a very, very strong entry point in making something digital, in creating all the data you need for AI and machine learning to actually take that metadata of what people digitally create and then basically do the models upon those. So, and as a key message, besides the fact that you see certainly that you know, technology like UiPath has been kind of much stronger growing through the situation we have through the pandemic. Other developments around AI have, if you look at latest Forrester as kind of charts here, have actually kind of been a bit put on hold, because everyone is trying to master how to, you know, become quicker digital. So they started and focused on automation technologies. But now again, there's a huge uptake in seeing how can I take the automation to the next level. And that's exactly what I want to express to you, to say, you know, automation is the starting point. As a developer, I'm actually creating an application. That application that we're creating is an automation combined with tasks people do with applications, and turn that into another application, an automation in that sense, that you can just run, and you can build a new user interface upon it and so forth. So I'll talk about all this a little bit more, but the key essence here is to understand that how strongly connected automation and machine learning or AI technologies really are, because it makes it very applicable. And that's kind of a key thing. And also that companies are very much aware of applying those technologies. It's being driven and discussed on the kind of leadership executive level down to the entire company. So it's a strategic movement. And that's why it's so important to put AI here into the combination, because that will be, like I said, the foundation for many AI technologies to be applied. Another chart I wanted to share with you, it's also very important, because this McKinsey chart shows you what companies are doing in terms of automating or digitizing their organization. And you see these 8 categories then on top is case management. Case management was the kind of initial workflow setup. So if you think of you're working with the systems or with multiple systems, then you build another system on top of it that captures all the transactions to the other systems like a case. And so in this way, you model the flow of a case along all these other systems. That's kind of a technical way of doing that, but that was there first before RPA was actually invented. And then RPA actually took over this more and more because it was much quicker to create exactly that layer by just simulating the user activity and using the user interface. And it could be done by people who are not developers, but also kind of just people learning a bit how to build a simple flow. So this is kind of the first two categories here you see are all about this kind of orchestrating or automation flows. The other categories are going into the cognitive space, image recognition, machine learning, and so forth. Also process mining to an extent. Well, we'll come to that on our products. Process mining is actually, you go into one particular system that is in charge for a particular process and you visualize it. And then you have voice assistants, chatbots, natural language understanding, all the stuff, again, cognitive, to understand what we humans produce to be kind of extracting information. And this is what Gardner then kind of defined as, ooh, this is hyper-automation. So it's not kind of hype about automation, it's hyper-automation in the sense of you actually are able to use all these technologies together to digitize complex problems and real processes, business processes. We actually have cover all of these areas, plus have some additions, because we know when you automate, you need to kind of support process change management. So how do you track the idea from the actual deployment? So we have a product called Automation Hub to capture this and make that transparent as a portal. We have a robotic twin, so you can really run on your desktop your automation and you can run it in parallel. So that really reinvented the whole concept about attended automation, as we call it. So kind of, or desktop automation, that you can run the robot in a separate environment without any kind of virtualization desktop software. Just using some feature within the operating system is something that we are quite unique with. And then we actually went also into the test automation space, which was totally different to our usual RPA space, which is all about business processes. And the interesting part around test automation is we tackled that because we realized when you create all these automation flows, you're actually you're turning real processes people do on applications into software. You turn them into automation flows. It's software, it's apps in a sense. And when you turn it into apps, you have, of course, maintenance. So there's a new maintenance challenge around kind of maintaining those apps, those automation flows. So we said, well, the only best answer in all of that has always been test automation as part of continuous integration. And that's why we actually have a whole product around test automation. And yes, I'll mention it later on, we actually also acquired a company that is very big in API management. So kind of where you can define exactly all those flows through these data flows from different systems through the APIs, but now you can combine it with RPA, so it makes it much more powerful. It just kind of explains a bit why we are kind of ahead of the curve here from all the kind of automation platforms, because we have, addressed all the other aspects that are very important for customers running very large automations. So what is the AI part in our platform? We, first of all, we built a platform that is not just RPA and not just robots. It actually covers the entire end-to-end process in implementing it as well. So from the discovery to find automations to building automations for different types of users. So if you're kind of a developer, you'll get kind of the Studio and Studio Pro if you're kind of doing test automations. But if you're just a kind of not a technical user, a subject matter expert of a business process, an accountant and so forth, and you want to do your simple automations, we have another product called Studio X. So we really want to address everyone, and we want to address also the people who are not developers to automate their tasks, because we want to introduce our platform as a productivity tool. Then there's the whole area around managing. If you create a lot of workflows and so forth, there's lots of areas around managing that. But also a very important point that Andreas alluded to, when you have many models and you're retraining models, how do you kind of manage the deployment, the putting them productive? Maybe that model has become worse, so you need to kind of roll back and so forth. All those kind of management questions here you need to kind of look at, or data management and so forth. And then, of course, engaging, just a second. Oh, I need to sneeze. No, it's not coming. So engaging, meaning we want to make it so that people can use and consume those automations that have embedded AI and so forth in a very easy way. And so that's another area we are kind of concentrating. And around all this, we put kind of a product that helps you for governance and measure. So we have an analytics component and so forth. So you see, we will have really the full-fledged part of what you need of a platform to cover all the challenges around automation and not just one particular part. But in the AI part, we have, first of all, in the discovery area, we have process mining and task mining. And I'll talk to it and show you a bit more as we go ahead. But task mining is, in that case, I really have no clue what I'm going to find. I'm just recording 5 people, what they're doing throughout a week. And then just looking into the data, a machine learning algorithm will detect where are good opportunities of tasks they are doing that should be automated. Either they're very repetitive or they take a very long time or so forth. And that's what kind of task mining is throwing out here. So we apply machine learning to find and discover automation opportunities. In the build area, we have a product around the, as we said, the ability to take in functions or library functions that allow you to extract information from documents, even handwritten. You can define and set up appropriate taxonomies. You can drag and drop machine learning models from your from the AI center, from our machine learning engine into it, just like a function call. And that makes it very easy for developers to just kind of call those. Also we have a whole function that Andreas already alluded to in terms of AI computer vision. So we can detect objects, you can train, you can use any kind of particular kind of computer vision model and leverage that. And there's a whole load of ecosystem skills of machine learning models that you can just upload, ingest into our system, or you can even link to other machine learning engines if you want to use Data Robot, H2O, or anything else in that regard. So we have these robots run machine learning models, attended and unattended, which means unattended is it runs in its own virtual space or machine, and it has its own user ID, and it runs 7/24. And attended means it's on my desktop, so I'm controlling it. I'm kind of triggering the workflow, and they can communicate to each other in all kinds of ways. On the management side, we're solving that particular challenge that you have in managing all your different models and versions and so forth, and making sure it's always kind of up to date. And we also have a whole analytics module called Insights, so you could actually see some of the kind of data points that are relevant for making sure that the model is effective and so forth, which you can actually put into Insights or visualize if you so wish to. And in the engagement part, we have chatbots, we have an action center, which is basically like a task manager. So if you think of how do you coordinate working with robots, so it needs human supervision. So best example, and I'll show that in a second, document understanding. How do you do the data validation and so forth? It needs human intervention. So what we have is this kind of queue. So you log through the portal, through the automation cloud, you see your actions in your queue, and then you can pick that action. Okay, I need to validate a document and check whether the data was kind of correctly extracted. press submit. So that kind of what we call human in the loop activity, that is part also of our platform. And that comes to the Action Center, which is in principle a portal to operate. And of course, chatbots. So you can kind of have that all integrated with an NLU that understands the instructions and then executes and fulfills the execution of whatever intent you have configured in the chatbot environment. So these are all kind of parts of our platform that are AI related. But the key thing is we are, I think, one of the few platforms that has its own AI engine, which allows you to put the engine on-prem, so in your own environment, but also in the cloud. So we support both. And yes, you can imagine, of course, we can do a little bit more in the cloud in many ways than on-prem, because we have much more processing power there. And so that's also something that you have in the platform. But it's a different way. We took other vendors were in this space were just saying, oh no, we just have, you can pick the engine and use an API and you're in the other environment. But we really kind of created our own AI or machine learning engine environment. So the things I want to talk to you about around our UiPath platform is kind of to address basically these 4 areas. We want to automate more, we want to discover more, and use in that sense AI. And then we want to operationalize AI and expedite it. And let me kind of talk about this a little bit more. So automating more means that we are, if you look at in business or real-time processes, how do we make sure that we actually can automate more in terms of increasing scope? So when you think of RPA, it can do all the basic stuff of, kind of what you would do in program. So you can look into screens, you can extract data from the screens, you can process that, you can put it in other screens, you could take the data from screens and put it into an API, or you can take an API data, put it into a screen, all these kind of things. So it fills forms, you can create kind of emails, you can react upon kind of email events, you can even monitor what a user is doing and pop up and give suggestions. And so you can really fully fledged program everything you could program in a kind of a typical programming language to create a fully fledged app. But everything is basically rule based. It's everything deals with a structured data setup and so forth, and it's all around emulating the human, following particular rules. So that's kind of the core of it. And now we added all the other key elements that are very important, I would say, from a cognitive perspective, as well as from kind of a way to predict or to classify or to regress and so forth data, to make decisions or to give recommendations, or to process data, to make kind of to combine that with the algorithm, so the algorithm will then take different ways. So in this sense, we now extended the RPA capability with the AI capability, or narrow AI capability, in understanding documents, understanding kind of vision, understanding forms, so kind of semi-structured information in that sense, completely unstructured information of email that's written and normal text, and using natural language understanding in connection with that. So, or understanding sentiment, kind of looking at the text that is written and identifying whether it's kind of a negatively or positively, and all those kind of things that you would expect with vision, with text, with documents to extract information, from screens. So everything you could imagine that is typically in the cognitive space is basically covered within our platform. And so this is basically how we enable to automate more. And to confirm to you what it means to automate more in the business sense, that's basically the benefits of, for example, being able to do intelligent document processing, which we call document understanding. And what that actually realizes is this whole flow of you basically take a document, you extract the information of the document, you then assign it to a person in the sense of supervising, giving feedback around data that maybe it's not so confident to have been kind of understood correctly, or even classifying a document so that it is able to extract the information. And many systems in the past, it was always like there was the vendors of document understanding who were concentrating only on extracting data in the kind of best way. And then there was the RPA, the automation space, and now it's all in one. We have it all integrated. Plus, we actually now do AutoML, so automatic retraining of the models. So when you have a model that is already trained on, for example, understanding receipts, you can now use that model, and whenever the knowledge worker gives an update of the data or whatever has been extracted, the new there will be generated a new model. So all this data comes into a new model, will be retrained, and once the model is ready, it will be kind of swapped with the other productive model and then put into play. We use that, of course, ourselves for extracting invoices. We process around 1,000 invoices a month, and we have significantly, after 4 weeks, really reduced this involvement of a person validating the data as we improve the machine learning more and more. And that's one of the biggest areas of scope that you find in business. The way it looks like, just to give you a quick introduction, is like this in our software. So you have on the right side the actual document, on the left side you see the data validation screen, you see it's even handwritten, and then you can kind of validate this accordingly. So that's kind of the first thing, to build a whole kind of human in the loop construct so that people can validate the data. Then also being able to, if you get a document that you can't classify or the system can't classify, that it comes to you and then you can classify it, and you mark the elements on this document that give away what type of classification that is. And when you press save, then in the next round of retraining and so forth, that kind of new update on these objects will be coming into the system automatically. So that's kind of and that's a big area around in business where people need to automate. It's lots of paper meant for people to process and so forth that we are covering by making automation more intelligent in that sense. And that's why that's automating more. Now, discover more is a very big challenge. So one of the biggest challenges in generally in automating and digitizing processes in business is actually to have a healthy pipeline of the opportunities that are there to automate. And in order to do that, we have two products which we introduce. One is process mining, that really addresses by logging into the system, looking into the logs of an SAP system, where it then can follow the user having done a particular transaction from end to end, say, account receivable process, and then you can visualize that in the tool. I'll give you a quick peek how that looks like. And then task mining, as I mentioned, which is really, you don't know what you're going to find. You just look at all the tips and clicks a person did, and you're basically visualizing opportunities. So this here is task mining, as I mentioned. You log into the system and then you visualize each step that a person has done within the system in account receivables or whatsoever, and you can kind of narrow down and see how many people have done like the same way, the same steps. What that tells you is how much standardized the process is. And for automation, it's so important because the less the process is standardized, the more it is a challenge to actually to automate. So we can discover all kinds of challenges around the process by actually looking at the real data in the system. So this is why process mining is so important. The other aspect is, like I said, AI powered, which is task mining. That's where we apply real machine learning algorithm to actually detect it. And that's a very, very powerful means. And this is how it looks like on the left. So if you run it, you can say which applications maybe you want to block out. And also, of course, you're not capturing any personal identifiable information. It's just what you take all the transactions and then let the machine learning algorithm make the decision where obviously opportunities. That's a very, very important area in order to discover more. So understanding the process that we do, the steps that we do, and you could imagine maybe one day we'll even take that further in generating automations. But right now, it's really understanding it. Then operationalizing. Operationalizing is very important because, as Anders already mentioned, you know, in the data science world, if you're creating one model, it's productive. It needs to be kind of reliable. In order to make it reliable, especially in the business world where there are compliance challenges and so forth, you know, you cannot just throw a model in there and suddenly everything you've done before changes. So this is why the whole kind of operationalization is so important to apply. And that's what we have. You can upload any kind of serialized model, a Python code, you can import that, and then nicely people can just use it in creating workflows like a black box with input-output. You just send in the data, and then it does a prediction, or it does whatever else that you intended to do with that model. And so you can easily combine the two worlds of data scientists and developers in one system. And that really makes it kind of very powerful. There are many custom-built models where we applied that already in financial services and retail and all other areas where you can just, you know, whether it's fraud, whether it's matching resumes for, you know, kind of scanning CVs, or whether it's in the banking to understand if, you know, what is a particular customer doing in terms of getting data from the internet and so forth, and building a whole profile picture and identifying, you know, what all relevant information that you need to do for a decision. So that's operationalizing it, and we'll add even more and more feature into our platform to make that very kind of controlled in a way, because that's a very, very important fact in the enterprise world. But we want to, and more importantly, expedite AI or machine learning in our platform. And the way we do that is already, as you've seen, if you take automation, an automation flow, and then you combine a machine learning model, or you take multiple machine learning models, right? So for example, if someone wants to apply for a loan, there may be different machine learning models involved to predict whether this person is, you know, kind of would ever default on a loan or not. So you could, first model could identify what's the request the person is sending through, right? Oh, it's a loan request. You could use a machine learning model to detect that. Then you can use a machine learning model that, you know, does the actual prediction of, all right, given with these parameters, would this person, you know, likely to default and so forth. Just giving you an example that the power is actually in the multiple combinations of different models, and we have implemented one where we actually identify complaints. So even if someone is saying, I've been waiting for 3 weeks now, or so forth, is already a complaint. And being able to detect those may involve multiple models to kind of validate this information, but to combine them all and to put them into context, that's actually what you do with RPA. So you can basically control these different flows and have the end-to-end process and embed it into these different machine learning models. And in between, you combine something where, as you've seen with supervision or even semi-supervision, that you need user input, and being able in this flow to run different models, put the data streams into different, through different models, and then also involving the human to provide validation information is kind of key. And that's where we use these things like chatbots can be used. You can use the action center, as I mentioned. It's a portal. You log in, you see the action, you can kind of confirm and validate data. So that's very powerful. But we also want to encourage people to do their own automations. And what we created is, that's what I mentioned, Studio X. And in Studio X, we have a component that allows you to do OCR extraction of documents. So already we apply in a very simple way kind of machine learning to allow to extract information from documents. And then you can even build whole apps around your solution. If you create a workflow, you can build a user interface around it and just call it up with the URL, and there you go. You got a standalone application that even would run on a mobile. And most interestingly, our platform also has a data service. So like a normal database, you can create structured data tables, link them and so forth, and have the robots use that data. And if you think of machine learning models where you kind of work a lot with the structured data, if you need structured data to process around your workflows with your machine learning models, you can very easily make use of that. But as we are an open platform, there's so many components you can really kind of leverage in the AI world, from document understanding, from conversational AI, so kind of chatbots or NLUs and so forth, or specialized machine learning engines and so forth. All these solutions you see here, they're all part of our ecosystems. More than 300 integrations, and you can all kind of leverage them. And there's a whole marketplace you can go to, and they're free, and then you can kind of make use of them. One of the interesting products companies we acquired is Cloud Elements, and that's very much like if you have different data streams through APIs, and you want to even build event control around data coming from a particular application, or polling on particular data and so forth. For all that kind of structure, Cloud Elements is the right answer. So we are using what has been there for quite some time around API management in the full extent, and embed that in our platform. In the next release, you will see a fully integrated solution with this Cloud Elements technology, but that really brings it into another capability. So in this sense, we're expediting AI. We're kind of combining it with RPA. We're combining it with data flows through APIs and so forth. And you can just see that you can build applications. You can create UiPath apps, and then ingest any kind of machine learning model, combine them, and make them to applications. So it's actually an ideal platform. And our vision is that we want to address the following kind of 4 categories. So for consumption, the fact is that there are machine learning models out there, but it's not being effectively consumed. And we want to increase the amount of ability to apply and empower the users of having in their automated processes more machine learning capabilities. We also want to enable more the accessibility to developers. Not every developer will be a data scientist or dealing with data in the same way as the data scientists look into this. And there is probably a different way of working in this particular space. So just being able to drag and drop the models I need, like a kind of like a programmed class or whatever that I have developed, just drag and embed that into my code and make use of it, is something that is kind of key. And you see that there's a huge demand and uptake for many developers in RPA space, that they would just like to have these models that they can reuse and embed into their code. And also from an operationalizing aspect, although we know that the biggest challenge is around the data processing and preparations, but there was a big need also around operationalizing these models, making them so that they are in companies in a very operated in a very controlled way. And last but not least, of course, there's a real focus in AI. So Gartner, for example, says that the CIO nowadays is under much more pressure because they have to deliver more digital services and so forth. So they actually have to remodel their entire kind of operational technology stack, in the sense that there are 4 key technologies they are looking at. The first one is, of course, it's the digital workplace. So because everyone through the pandemic is working from home and so forth, enabling that. So that's that. The next one is already machine learning and AI. So there is a real demand for uptaking and bringing more AI into the business, but they need to put it into something, and that's where the third one was robotic process automation. So you see how tightly connected they are. And the last one is kind of having these distributed cloud environments. So of course, through the pandemic, the cloud movement, or moving more towards the cloud, has also established itself more and more through the pandemic, as well as people needed immediately a scalable and resilient solution in the whole infrastructure. So this is a bit of vision of what we want to do. And with that, I hope I've given you a bit of a view of our product and how it supports AI and what you can do with it from a kind of introductory level. And there's more that you can kind of leverage. So if you want to leverage more around, AI vision, around, we've got a whole AI summit where there's more details and so forth to leverage. If you want to see it in actions, there's, there's the art of the possible, the immersion lab, and of course, stay connected, make use of the UiPath community. So with that, I'm basically handing over to Radu. Let me stop sharing and hand back to you.
Thank you, Boris, for that call to action. So again, just to reiterate, check out our products, test them out on your own. Like I see a lot of developers still think that UiPath is this screen scraping a tool that maybe was true in 2017. Boris did an amazing presentation on how it happened.
Not even then, actually, to be honest, screen scraping was, maybe they started in 2005 with that.
Yeah.
That's when we wanted just to create an SDK. But then I realized, there's much more to it. And so that's why it's, it's a real important understanding that it's not screen scraping. We would have not grown otherwise.
Exactly. I mean, Boris did an amazing presentation of our end-to-end automation platform, because it is a platform that has multiple products within it, all aimed at automation. So thanks for that, Boris. So I was thinking maybe we can take a quick break, and afterwards I'm gonna get Radu do a really cool demo and talk about a specific use case that we did, in which we combined machine learning with our RP platform. So let's take...
So how long? Maybe 5 minutes break?
Yeah, 5 minutes. I'm just going to put on like a clip of UiPath that you can listen to, or you can go take a cup of coffee, and then in 5 minutes we can join back and you can join us and see Radu's presentation.
Okay, see you soon.
UiPath Assistant is software that runs locally on your computer. It's like a mini you that can do everything from managing your calendar to filing complex tax returns. In this example, I am an HR manager, and I start every day with an inbox full of resumes. Matching candidates to job openings is time-consuming and boring. Now imagine that I have my own personal robot assistant to handle this while I focus on more valuable and urgent work. My day starts with a reminder that my assistant is ready to review new resumes. When I start the process, the assistant launches a new copy of my desktop so I can carry on with my tasks without losing my mouse and keyboard. As the robot reviews each resume, it finds the best matching positions and sends an email response. If something unexpected happens, like an extra email attachment, I can take over the robot's desktop and choose the best document for the review. Then, I can go back to my work. Once the robot finishes, I can see the sent emails with personalized job matches for each candidate. To learn more, visit uipath.com. At UiPath, we believe that every person should be freed from the reoccurring and repeatable tasks that steal time and productivity from the workforce. Let's look at how UiPath is rebooting work with our vision for a robot for every person. UiPath Assistant, Studio X, and Automation Hub are three of the products that make our vision of a robot for every person a reality. Let's see how they work together to fundamentally change the way we look at work. UiPath Assistant is software that runs locally on your computer. It's like a mini you that can do everything from managing your calendar to filing complex tax returns. In this example, I am an HR manager, and I start every day with an inbox full of resumes. Matching candidates to job openings is time-consuming and boring. Now imagine that I have my own personal robot assistant to handle this while I focus on more valuable and urgent work. My day starts with a reminder that my assistant is ready to review new resumes. When I start the process, the assistant launches a new copy of my desktop so I can carry on with my tasks without losing my mouse and keyboard. As the robot reviews each resume, it finds the best matching positions and sends an email response. If something unexpected happens, like an extra email attachment, I can take over the robot's desktop and choose the best document for the review. Then, I can go back to my work. Once the robot finishes, I can see the sent emails with personalized job matches for each candidate. Now that you've seen how to work with a robot assistant, let's look at creating my own personal automations with Studio X. Studio X gives people with no coding experience the ability to automate their tasks. Here's how it works. Every day, I onboard new employees. As part of the process, I download an Excel file, then visit a website to create a temporary password for each new hire. To automate this, I'll use Studio X to tell the robot to open the Excel spreadsheet. From here, the Studio X recorder will observe how I create a new password without me writing any code. Then, I'll tell the robot to save the password back to the temporary password column in the spreadsheet. Finally, I'll want to review the emails before they are sent in case I want to add a personal note. I'll show the robot how to create an email draft with the personalized password we just created for each new hire. Now, let's see our automation in action. When I click Run, the robot starts working. Once it is done, we can see it filled the Excel spreadsheet with a password for each new hire and created the draft emails for my review. Now let's take a look at how all of these automations are managed within my company. Automation Hub is where your company collaborates to define and build innovative new automations. In the previous onboarding example, after I'm finished in Studio X, I want to share with others in my department so they can be more effective also. I can submit my automation for approval from my Center of Excellence, or COE. I can even suggest new ideas for the COE to build for me. After I provide all the information, the COE will review and assess my entry and the Studio X file and then distribute it to other HR managers after seeing that it meets their governance standards. Once the COE has approved and distributed my automation, I will see it added to my UiPath Assistant, and I can now run that automation at the beginning of my day, just like I did for the resume reviewer. Now you've seen how a few of the products in the 20.4 release come together to bring a robot for every person to life. To learn more, visit uipath.com.
So I'm gonna stop the videos. Hopefully everybody managed to get back in front of their screens, and you managed to get a nice cup of tea or coffee. So with that said, first, before letting Radu do the presentation, I saw that we have a question on Slido, and I'm gonna ask Radu to answer it. So Radu, the question on Slido was that how do you ensure you have a good or precise machine learning model?
Okay, that's a very good question, and in fact, a question that has different answers depending on the machine learning application that we're targeting. So, of course, during the development of that model, you're always gonna split your data set. I mean, you've seen in Andreas' presentation, right? You collect some data based on which you want to create a prediction model. You always split that into some training and some testing data set. So what that means is, you do all the refining of the model on parts of the data, but you also keep independent data sets completely separate during the learning phase in order to use that for testing, right? So you want to test the performance of the model after the model has learned. Now, in terms of the actual testing, the actual performance metrics that you're going to use, this also depends on the application. So you can go from things like an accuracy or or an F1 score, like more robust kind of performance metrics. And I'm going to give an example here. So let's say that I'm going to give an example where accuracy itself actually is not such a good good performance metric. So let's think of a machine learning model that is created on a highly imbalanced data set. So let's say you're trying to predict fraudulent transactions. In real life, fraudulent transactions is a very rare event, right? So it's just something that comes up maybe 0.5%, maybe just 1% of your real transactions are fraudulent. So just by having a very naive machine learning model that takes any kind of input and tells you that this is not a fraudulent transaction, will have in essence a 99% accuracy, right? Just because of how imbalanced your data set is. So accuracy itself here has no value. So then you start thinking about, how can you treat this sort of discrepancies in your data set, looking at false positives, false negatives, or more robust accuracy metrics like an F1 score. Of course, this is in the context of classification. For regression, you have a completely different set of performance metrics that you can use. So it really depends on the business application. So even if you think about maybe a prediction in the healthcare environment, there you care more about maybe minimizing the false negatives than minimizing the false positives. If I take a COVID test and it says that I don't have COVID, and I actually do have it, that's worse than having a test that tells me that I do have COVID when I actually don't have it, because I can always repeat that test and get rid of that false positive. So it really depends on the application, but there are a set of accuracy that are well known in the industry that you can apply either for classification or for regression problems. So with that being said, I'm going to dive right into presenting a very interesting use case that actually ties together everything that you've seen so far. So Andreas gave us an introduction to machine learning and how what is machine learning and how you can apply this set of technologies. Then Boris showed us the entire RPA platform of UiPath and the different parts of the products of the platform that actually touch machine learning and AI. Now I'm going to show you an example that puts ties all of these together. So the actual use case that I'm going to talk about is a use case that can be applied to pretty much any sort of company that sells goods or services, any company that sells some good or good product or service, and in essence issues invoices. Every finance department of such a company, specifically the accounts receivable department, has an interest in predicting the cash flow. So basically, I'm issuing an invoice, whatever I have in that invoice, that is tied to a due date, right? So this invoice should be paid by the end customer by that due date. Of course, in practice, the customers don't really or don't always pay their invoices on time. So there's always going to be this discrepancy between what you're supposed to be receiving by a certain date and what the actual cash flow, the money that you receive in practice. So this is the problem at hand. This is what we're trying to predict here based on this due date of an invoice. And of course, based on the customer behavior, right? That the customer that is supposed to pay this invoice, can we predict if the said customer is going to pay on time, or is this particular invoice is going to be overdue? So this is the prediction itself, the prediction that the machine learning model is going to do. But of course, this prediction has no value this is a mantra that we've keep saying during our presentation, if there's no action to be done afterwards. So this this entire machine learning model is going to be tied together with a custom application, all done in UiPath, that will basically let the account receivable team to act upon this prediction, right? To give them some time, you know, to focus their efforts in collecting this cash from the customers that have overdue payments. Okay, so that's the use case overview. This is a problem at hand, predicting that invoice is going to be paid on time or not. Then, okay, this is actually a project that we've done for a number of customers. We've actually tried it on our own data set as well. The current state that I'm presenting you right now is from a large manufacturer. So this is actually quite a happy example, because if you look at these numbers here, this is the numbers collected over a 2-year time frame. This is a large manufacturer, meaning that sells lots of products to many customers. As you can see, the number of invoices that this company has issued in 2 years is almost 150,000. Hundreds of different companies, hundreds of different clients, and some monetary some figures in monetary terms as well. The statistics that we're mostly interested in here are highlighted. First of all, almost or even more than 1/3 of those invoices that this company has issued over 2 years are not being paid on time. So you see here the percent of invoices paid later than due date is more than 34%. So there's quite literally a lot of data that we can base our decision upon. Also, if we have to put a dollar value or a euro value on these invoices, actually 40% of the money that they should receive are received later than the due date. Another very important statistic here that actually led to the entire success of this project was the average or the median number of invoices per company. This is very important, and actually this is one thing that led to the failure of this project for a completely different client. So as you see, even if you have this idea of a prediction model, we're talking about machine learning here. So it all goes down to a data. If you have quality data and enough data, most probably, and of course, you know, this is separable, predictable, a machine learning model will be able to pick up something out of it. So for us, the crucial statistic here is this average or median number of invoices, because if a customer has repeated invoices, then it means I have historical behavior based on which I can create a machine learning model. Imagine here that one customer maybe had 2 invoices per year, right? This is not enough data to derive the behavior of this customer. So then I'll have to think about, okay, maybe I want to pull these customers, create maybe, you know, baskets based on geographies, things like that, different countries. So this kind of data set that we're presenting here is quite a happy one. Lots of different invoices, and more importantly, lots of invoices for each customer. And many of them paid later than they should have, with a big dollar value attached to it. So if we go a level a bit deeper into the data set, we see that those 34% of invoices are paid in the later month, and the euro, I keep saying dollar, but this is actually euros, euro value of more than 150 million over this 2 years time frame. If we drill it down into even more into how late were those invoices paid, we see that actually a big number here are invoices paid even more than 1 month later, right? So actually this client and the accounts receivable are saying, okay, even if they're paid a few days later, maybe it's not a big of a problem. But we see lots of different clients actually paying their invoices with you know, later than 1 month than they should have. So this is the current state, right? This is how the situation is in the company. Obviously, there is room for improvement here. and room for a machine learning model to make an impact in predicting this sort of behavior of the client. So in terms of the solution, solution description, of course, the solution has been structured in a very classical way. This is something that Andreas touched in the introduction of machine learning. This is usually what you do for any sort of machine learning model you have. Of course, here we presume that we already have the data. So I'm not going to talk that much on the data engineering, the machine learning ops before actually collecting the data set, but rather you're presented with this data set that can come, from different applications, different sources. How do you model it? What do you do with it? Well, there are three main things that you do with the data set. First, prediction engineering. So first, you need to define very clearly in a kind of like a variable what exactly you're trying to predict here. So in this sort of for this sort of application, it's quite obvious we're trying to predict if an invoice is paid on time or not. So we really look at the due date versus the actual date when that invoice was paid for historical observation. And based on these two data points, you can derive variables like is late, a binary classification, or weeks late, right? How many weeks was this invoice late? 1, 2, 3, or more weeks. Then it comes feature engineering. These data sets that you have at hand, you start thinking about the different attributes, the different features that can influence a customer behavior, right? Essentially, the data that you have is that invoice, right? And all the hundreds of invoices that the customers have been received in the past. But from here, you start thinking about how can I derive this information to create features that can influence the predictability of the model. And the modeling itself, finally, this is just a machine learning model that we use. I mean, given the tabular and the CSV-like structure of the data set, even intuitively, you'll think that a gradient boosted tree, maybe random forest is what's going to perform best. In our case, XGBoost was the model that gave the best accuracy, the best performance. So maybe here another important aspect to consider when structuring this data in a format that makes sense also from a business perspective. So okay, I have created my features, I have created the variable that I want to predict, but how exactly do I implement it? So this is where from a business perspective, in order to make sense, we need to give the business some time to act upon this prediction. So essentially, we base our prediction, let's say every Monday, and then we leave 1 week. 1 week we leave free lead time for the accounts receivable team to actually start calling that customer or do something with the information that we predict to happen the week afterwards. In terms of feature engineering, we were presented with different historical data sets. 2 main data sets were used to create a total of more than 130 features. These features like, how many times was the customer late in the last month? How many times was this customer late in paying their invoices in the last 6 months? Or how much money were they supposed to pay and didn't pay? How many days they were late? So lots of different features in this respect. A very important data that actually turned out to be unusable was this credit limit. So credit limits were dollar values assigned by the business, but because we didn't have enough information or it wasn't robust enough, this was something that we couldn't actually use in our prediction. In terms of the modeling, one more time, this follows the kind of classical structure. 70% of the data. This is what I was explaining before. When you do the assess the performance of the model, you always need to split it into trained, validation, and test set. So this is kind of the 70% of the data is used for training, 20% for validation, and 10% of the data for testing the prediction at the end of after the model was created. So now, in terms of the actual results, so we wanted to present the results. This is how very similarly how we presented the results to the business. So we focused on a period of 8 weeks of test data for a particular country, right? So remember here we had data for different countries. We don't want to mix that up. That was also a requirement from the business. Some behavior have, clients from Germany, other behavior have clients from France. So in this 8 weeks time frame for a specific country, structure the results into first the prediction accuracy, right? So this is the pure machine learning performance. How well did the model perform? But also, right, you don't have. The business people tend to relate to quantifying results in monetary terms. So as long as you attach dollar value, some sort of money saved or things like that, then you catch their attention. So we did exactly that. Now, looking at the performance of the machine learning model, what I have here is a confusion matrix. So in that 8 weeks time frame, there were 2,270 invoices. So what you see on this column is being not paid on time. Out of these ones, we predicted correctly 92% of them. So 92% of the invoices in this 8 weeks time frame that were not paid, we correctly identified as not being paid. Then also for the ones that were paid, right? So we had 1,197 that were paid on time on that time frame. We predicted correctly 96% of them. So in terms of the machine learning performance, quite good results. You see here 92% and 96% for the ones that were not paid were actually paid on time. So this is the kind of performance metrics that you can look at, where we look at false positives, false negatives, this kind of structuring the results in a confusion matrix. Okay, but presenting a 90+% accuracy model to the business, still, you don't really catch their attention. You need to, how do you translate that into monetary terms, or how is the business actually going to use this information? So then for the second part of presenting the results, we're trying to quantify them in monetary terms. So here, out of that 8 weeks time frame, 2,700 invoices account for 9 million euros, and the ones that were paid late account for 3.7 million. So in that 8 weeks time frame, these 3.7 are paying late, and this is where we try to help collecting, right? So we're trying to predict these ones, which are the ones that are not going to be paid on time, right? And do something with this prediction, help the accounts receivable in collecting these results. So going one level deeper into this, the real cash flow of 9.3, our model predicted 7.7, but also for these 3.7 of the real cash flow split into invoices paid within the first week of the due date and after the first week of the due date. You see here, these are the ones where the accounts receivable can spend their time trying to collect, especially the ones that this 3.7 here, the predicted cash flow, that our model said that these companies are going to pay more than 1 week later than the due date. So this is exactly the kind of information that the business expects. Now they can relate to these numbers, and they can invest in trying to chase those customers. So if we look at the actual model output, looks like something like this, right? You have some unique IDs of your invoices, some document numbers, some customer codes, and the prediction that the model made, right? So the next step is, okay, we've created a machine learning model very capable in predicting the behavior of our clients. This is the kind of information that it outputs. How do you put this into a business process? How do you actually help the accounts receivable team into collecting this money on time? So for that, we've actually created a cash collection application. And this is where I'm gonna show you the live demonstration of this process in practice. So what I have here are actually a couple of virtual machines. So now I'm gonna put the hat of a finance department employee. I'm working in the account receivable team. I come at work on Monday, and I want to know which are going to be the customers that have, you know, invoices due in 2 weeks' time, such that I can spend this week on actually chasing them and trying to do something about the cash flow. So the first thing that I'm going to do is I'm going to start this process. So what you're actually going to see is on this VM, you're going to see a robot collecting the data, right? So this data set, we assume that it's already in a structured format. All this information that I have about my customers is already available into a CRM system, for example, or in SAP, right? So what I'm going to do is I come at work, I go on my, what you see here is my automation cloud account. So this is the UiPath automation cloud account. It's a cloud version of UiPath. This is a SaaS offering, right? In here, I have the different many products of UiPath. The one that I'm actually interested in are processes. So now this finance department employee can just trigger a process, trigger an automation just by pushing a button. So let me show you that. In here, you'll see I also have AI Center. So I'm going to show you a bit later all the things that you can do in AI Center, but also I have all of these processes that are being published. So these are in essence automations that I can run. So if I'm searching for this delinquent payments, I'm just starting this process. Okay, the process has been triggered, and you can immediately see on this VM that in this assistant, so this is UiPath Assistant, where you can see all the different processes that are run on this virtual machine. This has already started, right? So now I can continue my work. I can do whatever I want, knowing that in this virtual machine, my UiPath robot is going to collect all the data. So it's going to collect all the data for the customers that have invoices in 2 weeks' time and put this information from SAP into a data service, so into a UiPath database. From there, I can start making predictions. So what's also going to happen in this automation behind the scenes is that after the robot collects all the data from SAP, it passes this data to a machine learning model. The machine learning model, of course, sits on AI Center, our machine learning platform. So this is how AI Center looks like. Also sitting on top of the cloud orchestrator or the automation cloud. In here in AI Center is the place where I can create all the different projects in relation to a machine learning model. You can see this one. This is the actual one that I'm going to use. There you go. Here behind the scenes, this is my UiPath already working, right? It's going into SAP and collecting the different data. So here in AI Center, I can see all the things that I can do, right? I can upload data sets. I can even label documents that I can basically generate labeled data for data extraction from different semi-structured documents. I can create machine learning packages. So here I can either create a custom build package. This is what we did, right? This model was created on our computers, and we've then uploaded it as a custom build machine learning model, or lots of different options here, very similar to AutoML, right? Things for image classification, image moderation, object detection, text classification, so lots of different NLP tasks, name entity recognition, sentiment. These are all out-of-the-box models that you can use. You can either train or evaluate in the form of a pipeline, right? Here in pipeline, I can create a train or evaluation run where I can train my said model that I chose as a ML package on a particular data set that I have uploaded, right? So I can even run any specific Python code in here. Once I'm happy with the version of the model, I simply deploy it. So then the UiPath robot behind the scenes, you see now is running a different automation. So after the robot scraped SAP for all the data, is passing this data to that machine learning model for the model to come back with a prediction. So we're now waiting just for the model to make these predictions. One thing that is missing in this demo is, okay, we're assuming here that the data that the model starts working with is already structured, is already put into SAP. In practice, you don't really have that. In practice, what you have are invoices. So then the missing link here is how exactly can I structure the data that is captured in those invoices such that I can then put it into SAP. So this is where our document understanding comes into place. So we've created machine learning models for extracting information from semi-structured documents. So what we have actually, documents like invoices, receipts, purchase orders, utility bills, all of these you can see here as an out-of-the-box package under UiPath Document Understanding. So these are already trained deep learning models, trained on thousands of different documents, each of them trained to recognize a very, various variables, all the common variables that you see in invoices, for example. So the way that it works is quite nice. Of course, this kind of models you can also, further train. So if you have invoices with more variables that you want to add, or maybe you notice that this out-of-the-box solution doesn't really recognize maybe the name of the company or the PO number in your invoices, that's fine. You can start collecting the data, label them, and use AI Center to further train this. Of course, using transfer learning. I don't want my model to forget all these thousands of invoices that it's already seen. So that means that I'm going to need less data to further refine this solution. So just to give an example of how that works, I have a very simple setup here for my demo where I can just select an endpoint. And what I'm going to do is I'm going to send this invoice. So this invoice is, you see, quite nasty. I can barely read it myself. And I want to extract all the information that I can find on this invoice, from invoice number, PO number, total, so on and so forth. So just by dragging and dropping this model here, behind the scenes, this document is going to be sent to my machine learning model. And in a second, you're going to see the prediction. So now, based on this semi-structured document, this is a document that the model never seen before, right? It was in the training set, to be honest, I don't know that for a fact, but this is just one of those examples you can use in production, and directly on this document, you can see immediately recognize all of these different fields. So then this is how from semi-structured information from the actual invoice, I can extract all the data that I can then put into SAP. Now, the accounts receivable, when it started that process, the robot took the data from SAP and run the data via a machine learning model already deployed, just to assess the risk of having an overdue invoice. So now you kind of have the entire pipeline of this, right? From invoice to structured data using document understanding. Then you have the UiPath robots that take this structured data and put it into SAP. At some time, accounts receivable employee comes in, runs a process that takes the data from SAP already in a structured format, puts it in our database, and runs a machine learning model on this information based on historical observations of a customer interaction to make a prediction. So now the missing piece is now we have the predictions. I see that this is still running. So now the final piece is, what do I do with this, right? How do I integrate this into a business application that can be used by essentially non-technical people, right? People in that accounts receivable, people in the finance department, then they just their job is, you know, in chasing the customers to pay their invoices on time. So that is also done using our platform, but a different product in the platform, namely UiPath Apps. So with apps, I can create this any kind of application UI basically. So I can create something like also here on no, not actions, apps. In apps, I have a custom build application that makes the link, you know, takes all this data and presents it in a human readable format. So this is the one that I want to start. So now this app. Okay, this is very secure. No, it's actually user. Oh. Okay, so this now application is custom built for this process. Let me actually see if okay, this has just finished in running the predictions, so maybe I can start this one more time.
So just to let people know that what they're seeing on Radu's screen right now, and what they're going to see is basically an app that was built using another product of ours appropriately called apps. So this is what you basically you can use to create applications in like a low-code, no-code way, and that's exactly what we did for this particular use case. But I can see that I think Radu maybe had some internet issues, because I can see he dropped from the live stream.
Yeah, that's all it looks like.
Okay, let me, in the meantime, while we're waiting for Radu to possibly join.
Yeah, maybe you can pick it up.
Yeah.
Perfect.
Yeah, his Zoom disconnected. He just left, and so he's going to be back in a minute.
I mean, there were some. Let me see. There was.
Oh yeah, we can actually address some of the questions on Slido. So let me just bring that up quickly. Maybe I can even share the screen and share answer some of the questions that we have on Slido.
Yeah, here's a question saying, does the platform need a lot of browser resources when using it?
Yeah, I mean, our robots run on desktop, and the majority of the applications we have are run on desktop. But we do have some services that run on the web, and this is something that you have seen. So we have our cloud automation platform that basically you can use to orchestrate all of these processes and all of these apps that you have created. And also we have all sorts of other products that run within our automation cloud platform. Like you've seen AI Center, which is this tool that we have for managing and building and deploying machine learning models. Then we have Data Service, which is this tool that you can use as a database for building applications. I can see we have Radu back as well.
Yeah, my Zoom disconnected. Apologies for that.
We kind of, we're still answering question, but to be very clear, so does the platform need a lot of browser resources when using it? So you got to see it that the robot is running in its own environment in terms of it's a runtime. So nothing of the browser is being used. The browser is just the UI.
Exactly.
So you submit the data, and then all the processing is done basically on its own processing unit, depending where the robot is. So if the robot is on the desktop, it's on the desktop. If it's in its own virtual machine in the backend, it's in the backend. And then there's this AI engine, which is its own node, basically where the machine learning model is being executed. So again, that is basically an AI robot, as we could say, which is running in its own as its own processing entity. To understand our architecture, we have robots and we have an orchestrator. The orchestrator is kind of like the management component. And all these robots are connected to the orchestrator. The orchestrator knows which robots are available, and the workflows that I create, the automation flows, I deploy to the orchestrator, and then they are ready to execute. So the execution is not happening in the browser at all. So that's kind of
just to add on that, you saw that when I started my process from the orchestrator, from the web page, there was actually a robot in a VM, right, that was going into SAP and collecting all this data. So the execution of the automation happened inside of that virtual machine. And the same kind of behavior happens here. So now that I have connected to this custom application, this is what the accounts receivable sees. All this information is being pulled by the UiPath robot from a database after the data was extracted from invoices. And now the accounts receivable employee can click and work with this application. And you can see when I clicked on this first invoice, here in my robot tray, an automation started, right? So now what happens is a robot behind the scenes executed the task of looking for this customer 108739, right? And running all these historical invoices for this client, right? This execution happens behind the scenes on a virtual machine. So from a user perspective, I don't need to care about that. So now I can take lots of different actions here. So, okay, with this invoice, this amount, 351 euros, has a high risk of being overdue. This customer is not going to pay the invoice on time, right? So now I have these custom buttons that I can use. So for example, I can contact sales. If I click on contact sales, I can link this to any kind of messaging platform. In our case, we link this with Slack. So I can say something like, this is urgent, I don't know, chase the customer. When I click on send, you'll see another robot starting. So what has happened is that a robot takes this input and sends a message on Slack for the salesperson that is dealing with this account. All of this data is being pulled by the bots from different places. So now if I open my Slack, I see here that Danny Robot sent this exact information to myself, right? With the customer details and all. This is completely customizable, right? All this information, I can decide how the robot notifies me. Of course, this notification can be done by email. It can be done by all kinds of different applications because, right, the platform, the RPA platform is agnostic to this technology. So the bots can connect pretty much to any different application. So here I can even send an email and I can say something like this. When I press send, the exact same thing is going to happen. A different robot picks up this input, connects to my Outlook, and sends an email to this address, right? So the accounts receivable team member doesn't really have to do all of these actions. These are the actions that the robot makes for them, right? So this is where we kind of like close the loop in, okay, we started with invoices, semi-structured data. We use document understanding machine learning to extract this information, put it in a structured format, put it into SAP, have robots every week taking the data from SAP, running a machine learning model that was custom built for this client's data, and presenting it in an actionable format here, all being tied together with the different components of our RPA platform.
Yeah, so, and that's a key thing that you're saying, you wrap around a whole application here with the data, with action buttons and then pop-ups, and that then issues workflows that are executed on the robot runtimes to then do the thing that usually someone would be doing manually. And what we can do with that is we can now certainly process all of that data and capture and follow up with all of those customers here that are delinquent. And what, from a business perspective, we are handling here, we're actually mitigating risk, right? From a business perspective, it's risk. It's risk that they have less cash flow than they can kind of predict with. That cash flow is important to pay other suppliers, to produce things and so forth. So you can imagine why that is so important. There's another question, guys, that came here, which is from Hendrik to ask, what's the smallest possible use case you can imagine where it makes sense to apply machine learning? I think it's an interesting question because machine learning is not something like a universal tool. It's not just, here's the hammer and now everything becomes a nail, right? There's many problems that you have to ask for, but first, before you try to solve it, to ask yourself, is it really a machine learning problem? So is there some kind of a rule to it? Is there even many problems you can solve through decision tables? So actually it's kind of a more complex but nested way of a rule-based kind of assessment, which also would not be a machine learning problem. But what's a good kind of small typical example? You say this is a good example for a machine learning problem. Radu and Andreas, what do you think?
There are many things. I mean, whenever for anyone that doesn't really have that much experience in machine learning, I think a very good starting point where you can actually see results very quickly is all of these AutoML platforms, right? On these AutoML platforms, you can just put a data set in there, and a machine learning model behind the scenes is going to derive a prediction. And you can use this for text classification. I mean, everyone has some emails. You can just collect those emails and create a classification algorithm on those on that text. Other examples that I think are very easily for us to relate to are product recommendations, because we're surrounded by these solutions and we don't even know it, right? On Netflix, Amazon, all this online shopping, me searching something on my phone, and then it immediately appears in my Instagram feed, right? Someone actually profiled me with all this information that it has on the internet and actually made the prediction that maybe I'm interested in this product and shows me an ad like that, right? So there are many applications of artificial intelligence. Boris said it very well, and this is where we see this in practice as well. Many clients actually have very complex rules that you can address just with RPA bots, right? But at some point, the rules become too many to be managed, or there's variability in the process. And this is a key factor here. This is how you kind of identify if it's an AI application or not, if it has a very high variability, right? And that's how you know that a machine learning model can be applied here. I think for me, because I kind of went on from the actual question, for me, the easiest one to see some results would be a text classification, because that's a natural language that I can easily understand and read. And if I have the AutoML tools to create this machine learning model, I don't need to care about all the deep learning behind the scenes, and I can immediately see some results.
That's a very good one. That's a very good example. That's true. And then, of course, when the question of when is it worth to automate something, yeah, it's worth to automate if you look at the high volume of that particular activity. Is there loads of, even if it's just a few, less than a second or minutes, or say 1 or 2 minutes, but it's something that you do 1,000 times a day, definitely that is prone to be automated. Is it something that is, even if it's it can also be very complex, but it takes very long, then of course it's very prone to automate. Does it follow a particular rule that you've got to do this step and this step and this step and this step? Yeah, then it's also kind of, and then you look at it from a business value. So is that activity contributing to a significant task or value that if you can do it faster and shorter, you're achieving much more capacity for the people to work and so forth. So all these are kind of factors you assess when you think about, is that something to automate? And then when you target your scope to automate, then you ask your question, is that, to what extent could this be a machine learning problem? And that's exactly where Radu was explaining how that works. What other questions do we have here? What is our business model? I assume SaaS pricing plan, but what I'm asking is, how can I evaluate the return of investment using your typical business case as an example? So, okay, it's an interesting one. So this is where we also have this platform called Automation Hub. So when someone puts in the data around, here's an idea, then there's a whole process, follow-up questions that goes to what we call the center of excellence. When you set up and build out automations, you set up also an organization in the IT department that basically, or also in connection with the business unit, where people are that are looking at the idea and validating that. And from the idea, from the testing, implementing the entire end-to-end lifecycle process to the deployment, we basically have in this particular portal. In this portal as well, we calculate the return of investment, meaning when we assess, how much time does this particular process idea take? That's one thing. What's the value from the business process perspective in terms of, can we validate, so for example, someone takes 10 minutes and this request comes in every day, I don't know, 30 times or whatever is a task that that person has to do. So then you can easily calculate what the total effort is involved of a human. You can then figure out, okay, is there any kind of business value detected to that? So say if this is some activity in relation to, I don't know, finding fraud or whatsoever, then you could even identify what's the prevention value of money you have to that, and all those factors you put in. So we actually have a whole portal that does all this calculation. We even have a tool that helps for non-technical people to just record themselves. You press the button, it generates a process definition document, and all the measured data in that example flow, it takes and puts into the Automation Hub portal and calculates the return of investment value. So all that to understand, what is the value of my automation pipeline, we have actually addressed to an entire product. And that's kind of how we typical deal with that. I hope I was able to answer kind of the key thing around it. Our business model is we sell, of course, the robot licenses, the studio licenses, and so forth. But we also have a community edition, which is on the cloud. If you just sign up for the Automation Cloud, then you can immediately get started. You get some community edition licenses, and for your own purpose of learning, you can fully make use of it. You can download Studio, and it's the full-fledged environment to work with. So you can even play around and apply it and test certain things before you actually purchase it. So, and trainings in connection to that are also free with the UiPath Academy, so you can really make use of that as well. What other questions do we have here? Is there a connector to Google Sheets or Airtable? I know there is, so if you go on the marketplace, there are connectors to Airtable for sure, and of course also to Google Sheets. We have the connectors to Google Sheets and so forth, or Microsoft Excel sheets or SharePoint lists and so forth available out of the box. So when you go in Studio, you can easily just select the appropriate activity library, and boom, then it's visible. You can drag and drop and program with that as you go ahead. Even in our simplified version, the Studio X, the entire integration into Google Sheets or or Microsoft Excel sheets or SharePoints. And so for all these kind of Office tool integrations are there out of the box and easy to use. Then there's a question, in particular, of one of our competitors. Is it the same thing? Are we different? Yes, first of all, we are different. Our competitor, the one that mentioned here, is kind of concentrating, has its own particular engine just for the document understanding. And when it comes to kind of custom built machine learning models, it's not in the same way. They don't have an own engine like this that you can just, do all kinds in a flexible way with this. That's where we are definitely quite different. They also don't have the robots that are embedded with computer vision capability. To that extent, that's not what they have. They would rely more on APIs in that sense. And I don't know, guys, any other comments around uniqueness of our platform compared to this? If you come up with anything, Radu or Andras, if you all see the question here, but I would say that's kind of in essence the a big difference, and it's really scalable because you can run it on-prem and in the cloud. And most automation platform vendors or RPA vendors would always depend on either an API to a technology that is only in the cloud, and we can also deliver that on-prem. There's still a big need for that to be on-premise in some very compliant architectures. So where can you start? Radu has very nicely kind of put it forward here. This is where you can find the academy, all the free trainings, and this is later on where you can actually just start a trial, just sign up, and it's no cost involved, and yeah, play around, really make use of it. Just checking whether there's any other question that we have not. There was a question whether we share presentation material. I don't know how that is handled within WeAreDevelopers, but we'll come back to you on this one. And I think that's it. Are we at the end, or are there still some more questions?
So hello, Sead is here. Thank you very much for the workshop. Thank you also for answering all the questions. There is still a lot of thank yous in Slido and also in our inbox. So Boris, is there anything that you still want to share with the community so we actually know how to start? The Academy is a good starting point, right?
Absolutely.
Maybe you want to share your Twitter handles or something, like where can people reach out to you again, Boris, Radu, and Andras?
Yeah, we can share that with you. We don't have a slide now with all the Twitter handles, but you can find me on BP Krumrey, and Radu and Andras.
You can find us on LinkedIn.
Okay.
Okay, so that's the best way to reach out to you, right?
Exactly.
Okay, perfect. Then, yeah, did you enjoy the workshop yourself?
Yeah, absolutely. I think usually when we do this, we have a little bit more interaction, but we don't know how many people are really online. And or most importantly, we hope that everyone else kind of enjoyed it, or it was interesting or meaningful to them. That's the most important thing.
I do think so, and therefore I would also like to ask everyone who watched the workshop to rate the session, also in Slido, so you can give 1 to 5 stars, whereas 5 stars is the best one, so please just rate it. And I just want to say thank you very much, Boris, thank you very much, Radu and Andras. I found it personally also a very interesting workshop, very simple stuff that you can do with a big impact on the business. So just want to encourage everyone, if you have an idea on how to solve some business processes internally with that solution, just give it a try and reach out to these wonderful guys. So with that said, we are going to a short break and coming back in 40 minutes again with our afternoon presentations. Again, thank you, Boris, thank you, Radu, thank you, Andras, and see you hopefully soon again.
Thanks.
Thank you.
Bye.
Bye-bye.
Digital transformation has failed to take off because it hasn't removed the endless mundane work we all hate. Automation can solve that by taking on repetitive tasks for us. Unleash your potential. UiPath Reboot Work.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.